a recording for the Unit 4 lab, which based on today, you'll be seeing this coming Friday when you initially need to start looking at it, taking care of your equipment, those sorts of things. All right, so you can either, if it's not past November 6th or the due date of November 15th, you can get this from your class plan. Otherwise, you'll want to go to the main plan, and you're going to look for 4.04 in the color related to chemistry. Right, so for me, that's this light pink 4.04 laboratory. And click more. Right, read through the laboratory heat transfer just so that you get some of the background information about what we're doing. But the big thing you want to grab is this Unit 4 lab report with tables. Make sure you grab the file with that title, Unit 4 lab report with tables. I made some adjustments to the lab report to, one, include the lab table, and two, you got to show me some of your calculations. I'll show you how to do a sample one in this video. All right, and that file should look something like this. All right, it's going to start with this table that actually matches what's in your lab manual. So that's what you'll want from the website. Physical equipment, you'll need your scale. You'll need your thermometer, which comes in this kind of cardboard tube. You'll need, there's a pack of 4 styrofoam cups that are all tied together. You're going to put those in pairs, labeled 1 and 2. And then there should also be a chunk of, or a little baggie with 2 nice thick rubber bands. Those you're going to put on the top cup that has the lid. And then that's going to make it so that when you put the bottom cup on, it stays tight, right? I can't shake it off. It's actually kind of hard to pull off. And this is forming a good seal. And then the last thing you're going to want handy is in your lab manual. You're going to go to the heat transfer lab on page 39. So start by making sure you've read through the laboratory information on the website in that first page in heat transfer. And then I'm going to use this video to show you how to collect things for trial 1, and then you'll have to do trial 2 and 3 on your own. So the first 4 steps are related to setting up your cups. All right, so again, the cup that has the lid is going to be the one that gets the rubber band underneath the lip. And then you put the other cup without a lid around that, and if you press through the rubber band, it's going to be nice and tight. It's going to be hard to get that bottom cup off. All right. The lid already has a hole in the center. You might have to kind of punch it in because it's perforated, but that's where we're going to put our thermometers. So that takes care of steps 1 through 4. Next it says measure out and record the mass of each empty calorimeter cup, cups 1 and 2. It says without the lids. So you're more than welcome to do that. I actually did mine with the lids, so long as you maintain that or remember that and always measure that way throughout the lab. So with my lid, this is 17.8. Really doesn't make too much of a difference if you do it with or without the lid, as long as when you take more measurements with stuff in there, you still do it with the lids on if you took your empty masses with the lids on. So 17.8. All right. And I already maxed out number 1 because I've started to put my water in there. Okay, because now we're on step 6. I'm actually going to switch this so that we can see both things. So I'm on step 6, which involves adding water. All right, so for me, I wanted to try to be really precise, so I'm using the graduated cylinder to measure the water. You can use one of the beakers too, but if you use the graduated cylinder, these only go up to 25, so you'll have to do it twice. I already have 1 round of it in the cup, so then now I'm adding my second round of 25 milliliters. All right, and then I'm going to lid this because I measured my starting mass with the lid on, so I need to include that in there. Double check whenever you do a measurement, make sure this is saying 0 when you start. All right, if it doesn't, this third button is the tare button, so you can press this to get it back to 0. But since mine's already at 0, I'm just going to plop this guy on here. You can't see it, but it says 67.3. So that's the mass of cup 1 with water, 67.3. All right, so to get the mass of just the water, I subtract those two numbers. So 67.3 minus 18.2 gives me 49.1. All right, this number should be pretty darn close to 50. If you get exactly 50 milliliters of water, you should get 50 grams as your mass measurement. So I was probably a little shy. One thing regarding the water, if you have distilled, use that. That's going to give you the best data possible. If you don't have distilled, next best thing would be purified like drinking water. And worst case, if you have to use tap water, that's fine. Just know that that's probably going to be a source of error for you because tap water has particulates in there that may cause a side reaction, affect the melting of the ice, something like that. So there's cup 1. Then I need to measure the starting temperature. All right, so I'm going to grab my thermometer. The red tip is what you want to make sure it goes in the water. So make sure you stick it in so you feel the bottom and then just lift it slightly from the bottom so you're not actually measuring the cup. Now my water's been sitting at room temperature for a little while, so this probably isn't going to change too much. But keep an eye on your thermometer. If you see it moving, wait for it to stop moving. Okay? So mine appears to be holding pretty steady at between 26 and 27 on my thermometer. So to make a best measurement here, I should estimate 1 decimal, all right? Because it's not perfectly 26, so I'd say it's more like 26.2. All right, so you should estimate 1 decimal point after the line that you know it crosses. All right, so final temperature of water in the cup, I can't do that yet, nor can I do change in temperature. So now I'm moving on to step 8, where it says fill cup 2 with crushed ice. So if you have an ice crusher at home, that's going to be the easiest way for you to get the ice. If you don't have one, what I did was I took some ice cubes in a bag, and I have a sturdy wooden rolling pin, and kind of lightly tapped it until all the ice cubes broke apart. But of course, ask permission before making all that noise and that sort of thing. Or at least tell people what you're doing. So here's my crushed ice. It's been sitting for a while, so there is some of it that is melted. And we don't want water in there, we want just pure ice. So I'm gonna sit there and grab from the top to get my ice. And you wanna use approximately 50 grams. You're probably not gonna get perfectly 50 grams because it all depends on the size of your cubes. But what I am doing, just to kind of get in that range, I can see that my scale is starting at about 12 grams. So I'm going to shoot for around 62. And again, I'm grabbing the ice and not the water. So there we go. That got me to 63, so I should have a little bit over 50 grams in there. And I'll lid it. Gonna make sure that says 0, and now I'm gonna get the mass of my cup with ice, which is 69.0. I'm gonna take care of my calculation later because now I want to move as quickly as possible. So I need to take my cup 2 with the ice and pour it into cup 1. So I'm going to do that as quick as possible. Put the lid back on cup 1. And we're going to stir it or kind of shake it for a minute so that this mixes really well. And then we're going to take final mass and temperature. All right, I got my thermometer in there, but I'm not using it to I'm using it more to plug the hole than I am to stir, because if you use the thermometer to stir, there's a good chance you might break it. So I'm just shaking it with my hand. And let's see, I see 213 on my computer. When it goes to 214, I'm going to stop and take my measurements. All right, there's 214. So temperature-wise, just because I can do that right now, I'm seeing like a 1.5 degrees. So that is pretty close to 0 as expected. So my final temperature is going to be 1.5. I'm going to take the thermometer out and get my mass of ice and water, which is 118.1. And then the instructions tell you to dump out the water and have just the ice left. All right, so this is something I got to be a little bit careful how I do this, because I don't want to use my hand to filter out the water, because my hand's going to actually start melting some of the ice because my hand's warm. So what I'm doing is I'm actually using my thermometer to help hold the ice back, and then I'm just going to decant off the water best I can without losing any of the ice. It would be better to have a little bit of water left than it would be to lose ice because I pour too far. So I think I've got as much water out as I can. Because I took my original mass with the lid on, I'm going to put it back on, and now my new mass of just ice in the cup is 47.1 grams. Okay, so that's the lab part. That's the process I have to go through for trial 1. From here on out, everything's calculated. So I'm going to set all of my equipment off to the side. I will need to use it again for trials 2 and 3. And let's start doing some calculations. So first off, I need my change in temperature. All right, so my beginning temperature was 26.2. My final temperature was 1.5. You always do final minus initial. All right, which is going to give me a negative number. So 1.5 minus 26.2. Oops. Now, here it says that I can just write the positive value down. I know that I've got a change in temperature of 24.7, right? All right, then I need the mass of my ice. So this was my ice before we mixed everything. So I'm going to do 69 minus 17.8. 69 minus 17.8. 51.2. So that's how much ice I actually started with. Then I have the mass of the ice remaining. So that is where I have the mass of cup 1 with the ice that's left. That was 47.1. And I'm going to subtract out the mass of cup 1 so that I know how much ice is actually there. It's going to be 47. Oops. Over here, 47.1 minus 18.2. Here, everything's in cup 1, not in cup 2 anymore. So it's going to be 28.9 grams. All right. Now, to get the mass of the ice that is melted, that's going to be the mass that I started with, 51.2, subtracting the mass of the ice that's remaining, 28.9. So 51.2 minus 28.9, so 22.3 grams of ice melted. All right. So now a calculation that is a little bit more complicated. Move the calculator out of the way here. Is the heat that's needed to melt the ice. All right. What we're actually measuring here is how much heat the water at the beginning gave away. All right, so the mass we're going to be dealing with is that mass of our original water, the 49.1 grams. That's where the heat came from. All right, the heat couldn't have come from the water of the ice because that only formed after the ice melted. So we've got 49.1 grams, all right, and we're using this equation, Q equals MC delta T, all right? So M is for grams, or for mass. C is that specific heat constant, and for water, we're assuming we use pure water, is the 4.184 joules per gram degree Celsius, okay? And then we're going to multiply that by our change in temperature. And we already calculated that. That was, from our data table, 24.7. And that's degrees Celsius. All right, I'm writing in all the units here because you can actually see that grams cancel, Celsius cancels, leaving us with joules, which makes sense. That's what we want to get. So let me plug this in. We've got 49.1 times 4.184 times 24.7. That gives us 5,074 joules. All right, so the water had to give up 5,074 joules in order to melt the ice. All right, and specifically to melt 22.3 grams. All right, so the next question, actually this, I'm going to write my answer in. I got 5,074 for my joules. Again, I don't need to write units in here. You're more than welcome to, but I've been skipping it because the units are all in the table. Now, the enthalpy of fusion. A useful number for calculations is how many joules per gram does it take? Because this is something you can apply. Say you have 1,200 grams of ice you need to melt, and you want to know how much energy that's going to take. If you know how many joules per 1 gram it takes, then you just multiply. All right, so to do that, since it took this many 5,074 joules to melt 22.3 grams, if we divide this by 22.3 grams, that's going to give us how many per gram? Oops. 5,074 divided by 22.3 equals 227. I'm actually going to round it up to 228 joules per gram. All right. So one last calculation you're going to have to do when you get through things is this, the percent error, right? Because we know through much better equipment than what we have, there is a known value for the heat of fusion of water. It's 334 joules per gram. We didn't get that number, so there's definitely some error going on in our lab. So to do that calculation, to do a percent error, get some more whiteboard space for me here. Percent error is calculated by taking your true value, what you expect things to be, subtracting your experimental value, what you actually got in the lab, taking the absolute value of that. So if you get a negative number, it doesn't matter, you just make it positive. Divide by the true value, and then to turn it into a percent, you multiply by 100. So for my part one of the lab, I'm going to take the 334, that is the true value, minus 228, that was what I got in my experiment, absolute value, divide by 334, because that's the true value again, and multiply by 100. So with the calculator, that's going to be 334 minus 228 divided by 334 times 100, which means I had 31.74% error. All right, not brilliant, not 100% awful, but because you may get some relatively high errors, that's what this next question for. List 3 sources of error. Right? We've talked about some already in this video. We've not gone through a total of 3. So come up with anything in this lab where we might have lost some heat, where it doesn't necessarily have to be a mistake that you made, right? But it could be just the conditions that we had, the equipment we had to work with were not perfect. Okay? And then question 4, again, kind of ties into this. You're going to find your average and explain why you usually do labs more than once. So why do you think you did 3 trials instead of just 1? So it's up to you to get your data for the last 2 trials. And of course, if you have questions, please ask.